Here's an example problem out of the text. So the answer is given in the text, but the method to go about the answer is maybe not straightforward, so I've provided this slide to talk about it. So the problem I'm doing is E2.6. So let's say we have some function y equals e to the x. I want to find a linearization at a specific point, x equals to 1. So how do I go about doing this? Well, I express y as my initial point, y0, plus m times some delta x. So this is the same form that we used for more advanced versions, but even for the simple linearization, the form is the same. I have a function y. It's the initial value plus the slope m times any deviation from our operating point, delta x. So I can take y0 over to the other side, and then we see that we have our slope m times our deviation, x minus x0. Or you can think of this as delta y equals m delta x. So what's our slope? Well, we take the derivative of our equation y, and we take that derivative with respect to x, and we evaluate the derivative at the point x0. So this is going to give us the value for our slope. So in this case, the derivative of e to the x is e to the x. We evaluate that at x0 for x0 equals to 1, and that gives us a slope of e. So now y minus y0 is the slope e times delta x, or x minus x0. So we can actually go ahead and discover what's the value for x0 and y0. So y0 is equal to e. x0 is also equal to 1, because that's the linearization point that we were given. So now y minus e is e times x minus 1. So if we decide to multiply through, we're going to get ex equals e, so the e's will cancel. So the linearization at this point is y equals ex.